Hello and welcome back, everyone. I'm really happy to have you back here at eREC for our last day. And today we are starting off with our startup pitch. And I'm really happy to introduce to you Aminata Bouare from Concular, who will talk a little bit about what they are doing in the construction industry regarding the recyclability of materials there and the platform they've built there. And afterwards, I will have Montgomery Jaritz from IonKraft, which is a spin-off from the RWTH Aachen University, and they have developed a nanoparticle barrier system for monoplastics. So really durable and ready for chemicals, etc. Plastics, which is also recyclable and even more cost effective than multipolymers. And for that, I'm really happy to hear more about it. I hope I said it all correctly, but Monty, we will hear more about that from you later. And for now, we will start off with Aminata. We will have a little presentation, and afterwards the time for some questions and a little panel discussion afterwards. So really happy to have you all here. Aminata, your stage. Thank you for being here and have fun.
Hi everyone. Hi Felix. Hi Monty. Thank you for having me here. So I'm going to quickly introduce myself. My name is Aminata. I'm a French engineer based in Berlin, and I'm working at Concular and responsible for project management and process optimization. So just to present Concular very quickly, we are a Berlin-based green startup, green tech startup fostering material reuse in the building industry. And the company was founded by Dominik Campanella, Julius Scherfüller, Mark Heines, and Lisa Hildebrand last year. And today we're over 15 people trying to make the world a better place. What is interesting is that before Concular was founded, there was another company called Restado. And Restado is actually a marketplace, online marketplace for also reusable or reused materials that was also founded by Julius, Dominik, and Mark. And the three of them founded this company 9 years ago and managed to actually sell over 200,000 materials through the platform. So Concular is a result of a lot of already experience and tryouts in the sector to bring us, let's say, to the next stage. And those two companies have been created to answer very specific needs, which is waste reduction in the building sector. And it's quite funny because when we think about pollution, in the industry, we think about transportation or fashion or let's say agriculture, but we rarely talk about construction. And it happens that actually construction is the biggest polluter in the world. In Europe, we're responsible for 1/3 of the waste in the European Union, and at the level of the world, we're responsible of 60% of the global waste and 40% of the global GHG emission. And basically, the main problem lies on the linear model that we have now, which is based on this take, make, waste economy. And in this framework, basically the implementation for reuse is not there. And to this day, actually 1% of the materials are reused. And the goal of Concular, the purpose of Concular, is to really shift this this economy from a linear economy to a circular economy and try to bring back those materials in the chain, in the value chain. And in order to do that, we try to really go to buildings that are going to be deconstructed and take those materials and replace them into new projects. So really to have what we call this one-on-one substitution, basically to really avoid the emission and the creation or the use of resources by using what is already there. So usually we call also this urban mining. And in order to make this possible, we need a few things. And the best way for us to be able to track and make this scalable is to rely on digital solution to automate this matchmaking between the demand and the need and to measure the impact. And that's what we're doing at Concular. So we are trying to create a new ecosystem, a new network for all the actors in the building industry to be able to exchange these materials. And what we developed is actually a platform where we can find different buildings, which we called building passports, in which we have all the materials in a data bank that we call material passports. And with those, we try to match with the actual demand. And this is all gathered on our digital platform that is online. Additionally to that, what we provide is also this expertise for assessing actually the quality of the materials, because the difference, for example, between Karstadt and Concular is that everyone can publish or sell those materials online. But what about the quality? What about the different norms? What about this whole framework? And especially in Germany, the construction sector and all the laws protecting or restricting this sector are quite demanding, and we provide this expertise and this quality. So we basically measure the reuse potential of these materials and provide additional consulting services to our project partners and to different stakeholders in the industry, architects, project developers, and so on, to accompany them in this direction. So that's what I was just mentioning before. When it comes to making this digitization of materials happening, the main focus is going on site and making sure to gather all the important information to make this free use happening. So it's not only necessarily about the quality of the materials, but how deconstructible they are. Sometimes we have, for example, some brick walls that are very nice, in good shape, but because of the joints, we cannot remove them, or because everything would fall apart. So there's all these different factors and all this different knowledge that we bring on site to gather important information and ensure that those materials can be safely extracted and then implemented, assembled into a new project. So that's what we do as part of what we call our reuse assessment. And then once those materials are properly assessed, whether it's related to the condition, the deconstructibility, and the pollution of the materials, because sometimes they are polluted, then we upload them on our website in what we call those material passports. So first of all, we have the building passport that gather all the information from the building. And then for each material, we create a material passport, which gathers all this important information that I mentioned. So the constructability, condition, and pollution, as well as the quantities. And then when all those informations are gathered, we can also extract some data from it, as, for example, the potential for reusability within the building, as part of a life cycle analysis, for example, etc. So once we have those information about the materials that are offered, we try to match it with the demand of the projects that are to be built. For example, we have a few projects that can be built in Cologne or in Berlin, etc. And then we compare with our algorithm the different needs and then make this attribution automatically. And this is, the main core of Concular, is to have this automated matchmaking to answer the needs, a bit like Tinder, so to say, but for materials. Yeah. And the main goal is actually for Concular to really accompany the industry towards this circular perspective. And now we really have this pipeline where we provide this assessment, and then we organize in collaboration with our project partner the construction of those materials, this extraction that we call either dismantling or selective deconstruction, and then we store those materials and then send them to the new destinations. When needed, we also, in collaboration with different manufacturers, we do some refurbishment, clean, for example, partition wall systems, or for instance, carpets, etc., and bring basically those materials to a new life somewhere else. So what is super interesting for me working at Concular is that the potential that we can basically bring everyone in these changes. So we have all the different capabilities involved at the company, and also we actually collaborate with all the different stakeholders with different expertise, whether it's part of the various engineering office assessing for example, the structural design or the resistance of the different materials that we have, or we work also with the construction company to organize the dismantling, as I was saying earlier, and additionally, sometimes we work with craftsmen, Handwerker, different manufacturers, or even sometimes certification offices to attest and recertify, for example, different elements. And this is basically so empowering because we really try to have this local approach of defining this new economy, and we really work with local partners in Düsseldorf, in Berlin, in Munich. And one of the biggest, as I was saying, purpose of Concular is to reduce the waste emission, the waste pollution created by these materials, and also the CO2 emission. And this is, of course, something that is good for the planet, but also good for our clients. And they actually can spare costs and CO2 emission, which they can then obtain as part of in some documentation in ESG reporting and whatsoever. So this measurement part is a huge topic for us, and we try to really make it transparent and show what is the bonus from our services and what the clients can obtain from us. And all this measurement is also happening within the app. So yeah, as I was saying, we also try to accompany all the different stakeholders in this process of changing and being more circular, and it comes through project management. So basically accompanying those architects, project developers from the beginning till the end of the project. So meaning during the reuse assessment and during also the sales of those materials. And additionally, when also it comes to re-implementing materials in their project, we advise them in potentially the design or the material choices to actually foster the reusability of the materials that they're going to implement in their project as well. Because this is also one of the biggest factors, right? Like how to basically not only reuse materials, but being able to design in a circular way. And in this direction, we're actually supported by a lot of people, and we have a lot already of success stories. For example, in Berlin, we are collaborating with Signa to foster material reuse in the Karstadt and Hermannplatz, we are also collaborating with Lindner, Zumtobel, and other manufacturers. We are collaborating with ISP in the frame of the Mercedes-Benz Arena, and I'm going to talk about all those projects just in a sec. So yeah, here you can see on the top left of the presentation, the Karstadt and Hermannplatz, which has a very, very interesting history and went through so many different changes. And we're super excited to foster material reuse in this framework. Additionally, we've been involved in a reuse assessment in Stuttgart for the Mercedes-Benz Arena, as I was just mentioning before. And additionally, we're also collaborating with Transform and providing materials for the Circular House in Berlin. Yeah, so a few words about Karstadt. We performed the reuse assessment in July this summer and really obtained a huge amount of materials that we are now implementing or providing at disposal for students in front of a student competition. And besides that, we're also working with David Chipperfield Architects. So it's super exciting. So just a few words about Karstadt and what is meant there. So David Chipperfield Architects have a super cool concept, and they are basically trying to do this refurbishment of the Rohbau, so of the core of the building. And what we're doing there is actually to help them reuse the facade in new parts of the building. And this is going to be a great role model for urban mining in Berlin and I guess in Europe. In this framework, we assessed a lot of materials with a huge potential for reuse, which you can see here. So windows, concrete slabs, of course, the facade, and various elements. In the frame of, as I was saying, the Mercedes-Benz Arena, we assessed the materials in August, and I came up with a lot of materials to save, and it was really interesting. We had some appearance on TV for this project, and in this framework we saved a few materials such as we can see here, lights, partition walls, also the recaro, these seats in the tribunes, and we are partnering with a few, already collaborating with a lot of architecture office to re-implement these products in projects. And the last reference I could present here is the Derek's house, which is actually an interesting project, because here we didn't do a reuse assessments, but we are only organized the cells of this massive house, and mostly actually of the wood structure. And it's quite interesting because we found already a lot of we already received a lot of requests, and soon this house is gonna find its new home, a new land to set and be reused in a totally different way, which is super exciting. So just here, I have a model as well from this house. So as we can see, it's mostly about the wood structure, and we have basically 2 floors to host that could be used either as a co-working space or at a cafe, as everything possible, which is great about building reuse. So yeah, as I said, we had a lot of different projects in Berlin, Düsseldorf, Stuttgart, and the next project coming up are in Munich. We are also in contact with potential clients in France, and we're just growing, and we hope to save as many materials as possible all over Germany and even beyond. So yeah, as I was saying, we are a team of 15 people, and what's so great about this is like the diversity of profiles and competences. As I said, I'm an engineer, but I also work daily with architects. Dominic has a background in finance and data management. Julius is a designer. We work also with software developers, of course, and also other colleagues have a background in sales, communication, politics even. So it's really empowering and refreshing to work in such a diverse team. So yeah, thank you for listening to my presentation. I would be happy to answer your question if you have any.
Thank you so much, Aminata, for this presentation. And I'm really happy to see what you are doing, which kind of projects you are already doing. And it's really interesting to see what is possible there. One very quick question before we head over to you, Monty. You told us that only 1% of construction material is recycled. Is that a number from Europe or is it worldwide? Can you tell us a little bit about that?
Yeah, I think it's worldwide because in Europe we have a much more, basically we have a lot of norms, and we have been talking about circular economy for a while. So we had different programs here. But basically, when you think about other like countries, especially in Asia or in the US, the potential for reuse is really not the same. And that's the main problem, and we're trying to change that.
Sure. And one more thing, is your platform, is your service available in Germany, in Europe, or are you operating worldwide already? Can you tell us about your market there?
Yeah, so basically for now we're focusing on Germany because, as I said, we have the toughest regulations here, and it's really important to basically organize a framework that is safe, I mean, legally safe for the customers and for our different clients. And now we're actually trying to also export and bring this solution to Europe. And since we already have the Euro codes and we have a framework that is quite common, we're trying to implement this, but hopefully we can take over and export worldwide.
Perfect. Thank you so much, Aminata. With that,
thank you.
I would head over to you, Monty. I will open your screen share now so you can show your presentation. I'm really happy to hear all about your solution to get us closer to a circular economy in plastics. We've been hearing all about it in the last few days. That is always the problem, to get a clear waste stream, to get good material in, and then of course good material out of the recycling. And I'm really happy to hear what you've developed and how it can be used in the future. So the stage is yours, Monty. Thank you so much for being here.
Thank you, Felix. Yeah, thank you for a very kind introduction. I hope everybody can see my screen. Yes, we are a startup from the RWTH Aachen University, especially from the Institute for Plastics Processing. And yeah, my name, as Felix said, is Montgomery Jaritz. I'm a mechanical engineer by training, and I've spent the last 10 years actually working in the field of plasma coating technology, which is also the technology that IonKraft is at the moment industrializing. So Aminata talked about one big pollutant, which is the building and construction industry. We are actually looking at another big littering and problem, which is the plastic packaging. So plastics actually have a great recycling potential, but however, only 6% of the almost over 200 million tons of plastic packaging produced every year is actually being recycled, and the rest ends up in landfills or is burned. But the good news is the awareness for this problem has risen in the recent years very dramatically. So public pressure and political pressure on companies to change to sustainable packaging is rising every day. And you have European laws coming in by the year, for example, imposing recycling quotas. There's, for example, one recycling quota of 50% by 2025 coming up. So changes coming, changes needed, and that's what we want to tap in. Because in many cases, a change to sustainable packaging is technologically difficult, because many products have very high demands on their packaging, and in the case of especially chemical packaging, we have the packaging not only has to be chemically resistant, but it also has to be completely permeation tight. And standard packaging plastics cannot deliver all this at once. And therefore, we have the situation that inexpensive packaging plastics are combined with expensive barrier plastics in one container, which makes them expensive and especially non-recyclable. And we can do better than that. We use plasma coating technology, with which we deposit a barrier layer on plastics that provide high product protection without inhibiting recyclability. On top of that, our coatings only cost a fraction of the additional costs that would result from the multi-material solutions. And our coating reactor design actually allows us to coat the bottles and canisters from the inside as well as the outside. And the coating on the inside has one layer which stops gases, solvents, and basically any other molecule that should not be moving through those packaging walls. And the chemically resistant top coat provides the necessary stability against alkaline and acidic environments. And this coating even has an oleophobic surface, which helps to reduce residue of oily liquids in the plastic container. So an easy to pour solution. I will later I will show you a visualization, a picture of this functionality. And a coating on the outside can further increase the barrier, and it can also function as an odor barrier, especially looking at recycled material, but sometimes this recycled material can be a bit smelly, and our coatings can then act as an odor barrier for this application. And on top of that, all of this is completely recyclable, which has also been approved by many official organizations, like, for example, the Association of Plastic Recyclers. So what does the coating look like? So basically, what we have is we have a silicon oxide barrier coating, which provides the barrier. We have an organic top coat. That is the coating that we developed, especially in the last 3 years. The coatings are super thin, so we're talking about coatings that are with coating thicknesses which are below 100 nanometers. They are fully transparent, chemically inert, and they're completely food safe already. So they're already approved by the FDA and the EFSA to be in contact with food applications. And the performance, as I said, we have a gas barrier against basically any kind of gas, migration barrier for solvents, toxic and aromatic substances, and we have a chemically resistant top coat. So, and we are also, furthermore, we're not limited to coat certain plastic. We can actually apply our coatings on any kind of packaging plastic that is needed for the application. So here you can see a demonstration of the oleophobic properties of our coating systems. The left samples are uncoated, while the right samples are coated with our coating system. And what you can see clearly is how the oil is being dripping off and beading off of the coated sample, while the uncoated sample remains fully wetted. This implies that with any kind of oil packaging, you will have an easy to pour solution, and you will get all the residue out of the bottle, which is a huge impact factor also for the recyclability of the container in the end. Here you see an example. Here you see an exemplary comparison of common multi-material solutions with our coating technology in terms of oxygen barrier. So we can see is OTR stands for oxygen transmission rate, and the OTR of the monomaterial polyethylene here is shown. So it's a polyethylene bottle in this case mostly used for agrochemical purposes. And you can see here the comparison to the co-extruded polyethylene polyamide multi-material, which brings a improvement of barrier of roughly threefold. And then you have the co-extrusion polyethylene and EVOH combination. And EVOH is a very strong barrier plastic in terms of oxygen barrier. And you can see that the OTR is actually reduced dramatically by it. And what you can also see is that our coating system applied on a monomaterial can reach the same, or almost the same OTR barrier as the coax. So we are well competitive even with the EVO barrier plastic, and we are much better than coax structures containing polyamide. So how does it work? How does it look like? The container is brought into a vacuum chamber, which is evacuated. Then a gas mixture is injected and ignited to plasma using pulsed microwaves. And in a process that's called plasma polymerization, this only few nanometers thick coating is then applied on the surface of the container. But now the question, why has no one done this yet? Well, first, because common plasma silicon oxide barrier coatings, which are already out there, are not chemically stable enough for the application of chemical packaging. Second, because the very high barrier performance is needed, especially if you look at the transport of dangerous goods, which is actually regulated in the European Agreement concerning the international transport of dangerous goods. And you can see here they have a concrete number that you need to reach. You need to get to below that. And furthermore, we have many different shapes and sizes of containers on this market, which makes the process development rather difficult. And in these three areas, we actually did extensive research, especially in the last 10 years, and we found answers to those challenges. So we have developed a chemically resistant barrier coating and a special reactor design for coating even large containers on the inside as well as on the outside. And with our simulation-based process development, we can quickly adapt our processes to every container size and shape. So what potentials are opened up by this coating technology? Well, our coatings, our ultra-thin coatings actually can apply it on monomaterials containers where they offer the same functionality as multi-material plastic, metal, or glass containers without affecting recyclability. And even reusable plastic containers with added barrier are now possible because the chemically resistant top coat can withstand the cleaning process with the aggressive cleaning agent. So the barrier stays intact even after the cleaning process. And as an outlook, something that I personally find extremely exciting is that we are currently in a testing phase with partner institutes to prove that our coatings can successfully decouple the filled product from the packaging material, inhibiting migration from contaminants in the plastic into the filled product. I mean, this unlocks a huge recycling potential because that would mean we have non-food grade plastics which can be used for food grade applications again, because there's the migration of any bad contaminants into the filled good is stopped by the coating. The field of application is therefore rather versatile. So our coatings can be used in packaging of basically any kind of sensible product that needs a barrier against gas or chemical permeation. And the applications range from agrochemical products like herbicides, insecticides, and fungicides and such, to pharma and cosmetic products, as well as solvents, oil, and chemicals. Also, as I said earlier, the coatings have FDA and EFSA approval, so they can also be used in the food packaging. Our reactor coating system, which we are building right now, so we have a prototype ready very soon, has a quite low cycle time, and our coating application therefore allows an inline integration at either the packaging manufacturer or also at a product filler. so that these coating machines, they can be fully integrated into current value chains without slowing down production. And yeah, we will soon be able to offer a turnkey solution, and the coating systems are very flexible in terms of production speed, as well as the container shapes and sizes, but also the barrier is customizable. It depends on the application that is possible. We can adapt our processes to any kind of application that is out there. We have a very strong core team, and it's really fun to work with those guys. The core team consists out of 2 PhD candidates, including myself, who have a combined experience in the field of plasma technology of almost 20 years now. We have a mechanical engineer with a business background and 5 years of work experience as innovation strategy manager, and a senior electric engineer with over 13 years of experience in automation and software development. So we together with some students, we are actually currently building the prototype and bringing our coating technology to market. And we were able to secure funding for our project. We are funded by the program called Exist Forschungstransfer, which is basically a government finance program to help in the innovative startup from science to help bring their technology to market. And within this project, we are currently building our prototype, which will be ready in roughly a month. But we also already doing a POC project with customers, and we are and by the end of during next week, we will start with a pilot project at a customer to prove also process stability in a production environment. And we also are currently growing our team, basically to make our vision become reality. And furthermore, the call to action, we are looking for partners. We are looking for a partner to industrialize our technology. So our competence lies very much within the plasma coating side. The plasma process, the reactor concept is what we're strong in. And we are looking for a partner to partner up with who is strong in automation and manufacturing, so that together we can bring a market-ready solution on the market in a quick manner of time. So I am very much looking forward to talk to all of you. Please get in touch if you are interested. If you have questions, I'm here. And yes, thank you for listening. And Felix, thank you for having me.
Monty, thank you so much for being here with us and this really interesting presentation on your process with that. Can you tell us a little bit more in depth about what you think are the next step here? You go, of course, now you're looking for first partner, but what is the scalability of it? How can you get it rolling in the next years?
Well, the next steps, so what we're doing right now, this is, as I said, the prototype will be consisting of 1 reactor. So 1 reactor will be able to get to coat 1 container, 1 canister at a time, and this prototype will be ready within this year. The next step will be to scale up this machine to a production level. So when we say we need 1,000 bottles per hour, 10,000 bottles per hour, it very much depends on the market and the application. The next thing would be to scale the system in terms of adding reactors to it and automate them so that they work together to increase the production speed, basically. So production speed is the thing that we will be concerned in the next year. And yes, for that we are looking for a partner because I think we should look for someone who has the expertise in this to actually help to bring this technology to a market-ready level faster than we could do it by ourselves.
Perfect. Thank you very much. I think you, maybe even you both, should definitely talk to one of our speakers from yesterday. I think Silke Hamm from Port F, from the Feddersen Group, who are helping with a lot of different applications in the startup world around the whole recycling. One other question coming in, Monty, for you: does the coating of your product complicate recycling in non-specialized recycling facilities? So is it possible to be used, for example, outside of the EU in recycling plants that are maybe less technologically developed than right here?
Yes, thank you for the question. It certainly is. So the recyclability of the coatings rely on two things. First of all, you have to see how thin the coatings are, right? So the percentage in terms of volume and especially on weight of the whole container and canister is so low that it actually doesn't make any difference when in the recycling process. Second of all, because we're talking about nanometers here, right? No, we're not micrometers or millimeters. It's actually nanometers, so super thin. So we have very little material that ends up actually in the recycling process. But also this thin material, the little material you have, is washed away when the flakes are washed in water or in caustic soda usually. So they are actually designed like they would actually dissolve by caustic soda in the washing process. So any kind of recycling all over the world will not have a problem with these coatings.
Thank you so much. So that's really a scalable solution for that. And
Thank you.
do you one other thing? Is it possible to be used with recycled material as well, or are there any challenges that might come up if you use a second life stream of plastics?
Yes, so we actually have already been coating recycled material to actually to have a look if that is actually feasible. And what you do is, you know, you what is important is the surface properties where the coating is applied. So mostly what is important is that the surface is smooth enough so that we can get a closed coating on the surface. With any kind of contaminants that might come out of the recycled materials, we have the possibility to use a plasma pretreatment, oxygen plasma pretreatment, to clean the surface of any contaminants, so the coatings can be applied properly. And we have already successfully coated recycled material, completely recycled bottles, and we were able to also create high barriers on this material. So I would say it looks very good in this regard.
Perfect. Thank you so much. And to maybe have a little further look on how we can face the challenges that come in the next years. Maybe Aminata, I can hand that first over to you. You are both coming from two different sides. One from the construction industry, Monty, you from plastics, which are both very important in the future. And to get to a circular economy in those will be one of the big steps looking forward to a sustainable kind of living and doing. And Aminata, how do you see the role of your company really in the long term? Do you think you will be able to get to a point where buildings are really built to be dissolved and built again, basically, or as we had it with the wooden house you showed, or what do you think will happen, and how will you be able to impact this?
Yeah, so thanks for the question. This is super interesting, because that's what I was referring in the presentation, that the goal is not just to have material reused in the new project, but actually to change the way we're designing things and to change the way we're designing buildings. And hopefully this is also something that is super interesting at our work and in the way we do things. We collaborate with architects, we collaborate with project developers, we collaborate with so many stakeholders who have the power actually to implement such projects. And what we hope is that having role models, having success stories, can already, bring this change in the industry and show, yes, see, this is possible. And that's what we're trying to achieve. And it's already so promising, because we already had some contribution with Arte, with different media, and we got a lot of exposure, which created this demand. So people are like, yeah, okay, this can happen, and I think this is the way it's going to happen, and I'm really looking forward to it. I think it's going to work. It's going to work. I'm optimistic.
Thank you so much. And maybe I can pose the same question to you, Monty. Of course, you're now in a very specialized field in plastics and offering one solution for a big problem. And of course, you won't be able to change the world only with that, I think, but it's a very, very important part. Do you think this is something that will really be used in the long term in a circular economy, or do you think it's only a step? And if it's only a step, what is the next one that's coming after that?
Yeah, thank you for the question. Well, basically, in terms of plastics, it's actually a very multi-dimensional problem, right? So you have the situation that what we need to have recyclable products, but we also need to have circular business models, for example, to enhance that. We have to have reusable products that are not disposed after use, but just cleaned, washed, refurbished, remanufactured, and used again. And I would say in all these different measures we need to actually achieve the circular economy for plastics, IonKraft can play one role, right? We can be part of the solution, as always. So what we're tapping into is the question: plastic products, they should, like especially packaging, they should be designed in a way that they, first of all, can be sorted properly, and second of all, that they can be recycled properly. And so we need solutions that bring product protection on the table, but also these two requirements that I just said. And I think in this field that, since our coatings, they don't inhibit the infrared sorting in the recycling process, so they can still be sorted properly even though they're coated, and furthermore they are being washed away in the washing field. So this can be one solution, but we need way more than these. So I would say innovation has to be a driver also to bring up recyclability in terms of plastic processing. I think we have still a long way to go, and I think and I hope that IonKraft can be one part of this development.
Thank you so much. And thanks to both of you for being here and giving us this presentation and those insights into your work. Really interesting, and I'm really looking forward to see what you can do in the next couple of years with that. And also thanks to all of you participating here and for being here and watch this presentation, for all your questions coming in. And with that, I would like to say a goodbye for now. We will see each other again at 10 o'clock when I will have Christoph Hillmann from ProLoga, and he will tell us about their automation and optimization processes for this recycling industry. But more about that in a few minutes. Monty, Aminata, thank you so much. I wish you a very good day. And for all of you, please head over to them, IonKraft and Concular, get in touch with them, and let's have a look how we can cooperate further to bring the circular economy to life. And with that, goodbye, thank you, and have a nice day.